Welcome, I'm Teresa Tarbuck, Assistant Professor of Chemistry. In this video, we will learn how to calculate the change in enthalpy, or the amount of heat absorbed by an endothermic reaction. Endothermic and exothermic reactions can be thought of as having energy as either a reactant in the reaction or as a product. Endothermic reactions require energy, so energy is a reactant. Heat flows from the surroundings to the system, the reaction mixture, and enthalpy of the system increases. In an endothermic process, the system takes heat from the surroundings, and so the temperature of the surroundings decreases or gets cold. A chemical reaction is exothermic if the heat is released by the system into the surroundings. Because the surroundings are getting heat from the system, the temperature of the surroundings increases. Everything that is not the reactants or products. Notice that we could determine the exact energy change for a reaction by measuring the temperature change of the system. If the system is isolated, no energy or mass leaves the system. Here we will approximate the energy transferred using standard enthalpies of formation. I'm going to combine 20 grams of barium hydroxide octahydrate with the appropriate stoichiometric ratio of ammonium chloride. This is about 7 grams of ammonium chloride. The 20 grams of barium hydroxide compound divided by its molar mass, about 315 grams per mole, is about 0.0634 moles. This reaction requires 2 moles of ammonium chloride for every 1 mole of barium hydroxide compound, or 2 times the 0.0634, which equals 0.1256 moles. Let's mix the two reactants in their stoichiometric ratios with a little bit of water under the beaker on a block of wood. The energy absorbed by the reaction comes from the surrounding water, air, and wood. We cannot easily account for the energy change in the wood or the air. The water inside the beaker comes from the hydrate. Water is a product of the reaction. Ammonia is also a product of the reaction, so one definitely shouldn't breathe the vapors. Any energy absorbed by the reaction has to be balanced by the energy lost from the surroundings. Conservation of energy. Observe that the surrounding water and water vapor is freezing to the beaker. We can calculate the enthalpy of reaction from the standard enthalpies of formation of the reactants and products. Here's a table of the standard enthalpies of formation for the reactants and products. The enthalpy of reaction is the product formation enthalpies minus the reactant formation enthalpies, taking into account the reaction stoichiometry. The table value for the enthalpy of formation of barium chloride dihydrate is negative 1,460 kilojoules per mole. The reaction stoichiometry is 1 mole, so the value negative 1,460 kilojoules is used. The next product is 2 moles of ammonia, which contributes 2 times the negative 80 kilojoules, or minus 160 kilojoules. The next product is 8 moles of water, which contributes 8 times negative 286 kilojoules. Since we are breaking apart, not forming the reactants, the formation enthalpies of the reactants are subtracted. 1 mole of barium hydroxide octahydrate adds 3,342 kilojoules, and 2 moles of ammonium chloride adds 2 times 314 kilojoules, because we are subtracting negative numbers. The final enthalpy of reaction after subtracting the reactants from the products is positive 62 kilojoules. This reaction is an endothermic process. Thank you for joining me to learn about endothermic reactions. To learn more chemistry, look at our other educational videos on a variety of topics.